Our moon, a beautiful bright orb in the night sky. But have you ever stopped to wonder, how did it get there? It's a question that has puzzled humans for centuries. Some imagined it was a giant pearl, others thought it was a god or goddess. Today we use science to uncover the secrets of the moon's birth, and the story is more dramatic than you might think. For centuries, our understanding of the moon was limited to what we could see with our naked eyes. But with the invention of the telescope, our view of the moon changed forever. We could see craters, mountains, and vast plains. This new perspective sparked curiosity. How did these features form? What could they tell us about the moon's past? The quest to understand the moon's origin took a giant leap forward in the 20th century. With the dawn of the space age, we could finally reach out and touch our celestial neighbor. Missions like Apollo brought back lunar samples, rocks from the moon's surface. These rocks held vital clues about the moon's composition and age, providing scientists with the data they needed to start piecing together the puzzle of its formation. The most widely accepted theory today is the giant impact hypothesis. Picture this. Billions of years ago, our solar system was a chaotic place. Planets were still forming and collisions were common. A Mars-sized object called Theia was on a collision course with the young Earth. The impact was colossal. The energy released in this impact was unimaginable. It vaporized Theia and ripped a chunk out of Earth. Debris from this collision, a swirling cloud of molten rock and dust, was flung into orbit around Earth. Over millions of years, this debris slowly coalesced, drawn together by gravity, ultimately forming the moon we know today. This theory elegantly explains several key characteristics of the moon. For instance, the moon's composition is remarkably similar to Earth's mantle, the layer just beneath our planet's crust. This suggests a shared origin. Additionally, the moon is relatively large compared to Earth, a feature not easily explained by other theories of lunar formation. The giant impact hypothesis is the leading contender, but it's not the only idea about how the moon formed. Some scientists have proposed alternative theories. One suggests the moon formed elsewhere in the solar system and was later captured by Earth's gravity. Another proposes that Earth and the moon formed together from the same swirling cloud of gas and dust. However, these alternative theories struggle to explain some of the moon's key characteristics as neatly as the giant impact hypothesis. For example, the capture theory has difficulty explaining why the moon's orbit is almost perfectly circular. The co-formation theory, on the other hand, struggles to explain the compositional similarities between the Earth and the moon. Section 4. Digging for evidence, moon rocks, and ancient clues. The giant impact hypothesis is not just a cool story, it's backed up by scientific evidence. Moon rocks brought back from the Apollo missions have been instrumental in supporting this theory. These rocks show that the moon's composition is very similar to Earth's, especially in terms of certain isotopes, which are different forms of the same element. This similarity points towards a shared origin, just as predicted by the giant impact hypothesis. Furthermore, computer simulations of giant impacts have shown that such an event could indeed create a system like ours, with the moon in orbit around Earth. These simulations, combined with the physical evidence from moon rocks, have given scientists increasing confidence in the giant impact hypothesis. Section 5. Fascinating moon facts, tides, eclipses, and more. The moon's influence on Earth is undeniable. It dictates the rhythms of our tides, pulling the ocean waters with its gravitational embrace. It creates the breathtaking spectacle of solar and lunar eclipses, moments when the celestial bodies align in a cosmic dance. The moon also plays a crucial role in stabilizing Earth's axis, preventing drastic climate swings. Without the moon, Earth would be a very different place, potentially less hospitable to life as we know it. Section 6. Our lunar companion, a story written in the stars. Looking up at the moon, we're not just seeing a celestial body. We're seeing a relic of the early solar system, a testament to the chaotic and creative forces that shaped our cosmic neighborhood. The giant impact hypothesis, with its dramatic tale of cosmic collisions and planetary rebirth, offers a captivating glimpse into the moon's fiery birth. As we continue to explore the cosmos, unraveling the mysteries of our universe, the story of the moon's formation reminds us that even the most familiar sights in our night sky hold secrets waiting to be discovered. Each new discovery brings us closer to understanding our place in this vast and awe-inspiring